Hello, colleagues. Uh, let's check that I'm heard. Please confirm that you can hear me. Okay, so let's start with the presentation. Today we will be talking about indoor GPS, precise indoor GPS. How precise? Plus minus 2 centimeter precision. For what? For autonomous vehicles, robots, drones, forklifts, and humans. So this first webinar of this sort, so bear with us in case there will be glitches. The agenda is very basic, so there will be intro about the presentation in general, then basics about their indoor GPS for those who don't know yet the details of the system. Then we will be talking about products and some new products intro. And there will be question and answer session where you can ask over the web, and I will be able to answer and even show in the dashboard their real life, how to turn on something or switch off or something. So let's go. Okay, basic problem that we solve is that GPS doesn't work indoor. And precision 5 to 10 meters that regular GPS gives usually not enough for the robot, for autonomous robot to move from point A to point B and not to kill anyone. There are many other solutions, which is great, which are namely ultra-wideband, Bluetooth, odometry, magnetometers, Wi-Fi, SSI, laser triangulations, LiDARs, many. All of them have serious limitations, usually either precision or price or size. And in one way or another, you do need to know location for the robot, for the drone, or for people. Our system, off-the-shelf, ready-to-use, precise indoor navigation system based on ultrasonic beacons, united by radio in license-free ISM or short radio devices bands, under control of the modem. And their location is calculated based on triliteration. So this is our very typical starter set that we are offering, and probably most of you are familiar. Each of the beacon is $69. The whole set is $399. So this set is covering up to 1,000 square meters in 3D with 2 centimeter precision. Let's already talk a bit deeper about two types of architectures that we have. I guess you may have questions about them, so please collect these questions, and I will be answering them also live if necessary. So once again, we do have two types of architectures: non-inverse architecture and inverse architecture. Non-inverse architecture is great when you have a noisy drone or a noisy forklift or a noisy robot, but you have a few of them. 1, 2, 3, 4, 5, something like this. So it's not particularly about number of beacons or number of robots, but about number of robots and update rate you wish. How the system works. The mobile beacon or hedgehog or hedge, which is placed on the robot or drone, is emitting ultrasound pulses under radio control of the modem. And overall radio synchronization is done between all the beacons with the modem. So in this way, in all architectures, modem is the most important element of the system because it provides the synchronization. The stationary beacons, in this case mini RX beacons, they receive ultrasound pulse, but they know when the ultrasound pulse was emitted because all of them are synchronized like GPS satellites to exactly the same time and to exactly the same clock. So these are the basics of non-inverse architecture. In inverse architecture, it's rather opposite. In inverse architecture, the stationary beacons are emitting ultrasound, and the mobile beacon is receiving. It's far more complex to do than in non-inverse architecture, because in this case, each mobile beacon must be able to receive ultrasonic frequencies, different ultrasonic frequencies. For example, in this case, 19 kilohertz, 25 kilohertz, 31 kilohertz, or let's say 45 kilohertz, 31 kilohertz. So in order to trilaterate and measure position in 3D, at least 3 frequencies must be heard, and direct line of sight or direct line of hearing must be available. So there are many questions regarding this, and let me kind of repeat. The system is based on more or less the same approach as GPS. This is why it has nothing to do with GPS technology, but we are using GPS in quotations because from many perspectives it's very much GPS-like. But instead of satellites, you have stationary beacons, and instead of your terminal, you have a mobile beacon. But the requirements are the same. So in order for the mobile beacon to determine its position, the mobile beacon must hear or see directly the stationary beacons. For 3D, at least 3 beacons. For 2D, at least 2 beacons. We usually offer 3+1 redundancy because if one of the beacons is blocked, the system will still try to recover and still provide you great tracking, even if one of the beacons is blocked because of redundancy. We have some other solutions, and I will be talking about today is TDMA. For example, okay, let's talk about TDMA a bit later, just not to confuse the guys. So once again, 2 major architectures, inverse and non-inverse. We have a special document, and this document is about selection. Let me open the website and probably share with you the website when you get the system where you shall go in order to familiarize yourself and see the data. So let me share. So this is the page, downloads page. First of all, of course, check the operating manual. And then operating manual is basically a pretty detailed document which is describing everything about how to start the system, how the system works, all their details about the dashboard, everything. Then there's a placement manual, which is basically guiding you through typical cases. 2D robot or 3D drone or people or multiple submaps. A good starting point for placing your beacons. Then quite many guys are flying, so we have particularly 2 documents about the drones, so check them, autonomous copter settings manual and pixel settings manual. Then there's beacon comparison because we have quite many beacons, so it's useful to see differences between them, pros and cons. And selection guide for those who are ready to buy, so there's selection guide between sets. So use it when needed. Then the next slide about particular use cases. Majority of you know them, so it's virtual reality for different kind of industrial and game applications, absolutely different types of drones, and even more different types of robots. Delivery robots, advertising robots, all kind of robots. But not only. So more and more people are using for real-life applications like tracking mobile assets. So you install the mobile beacon on your forklift or cart or any mobile assets, and you're able to track it and basically know what their asset did, when, why, what was the average speed, maximum speed. It's already everything pre-built. So there is a real-time, or there is a player. So let me show the player. And Okay, let me first switch it off. So there's a player. And this player is able to play back everything which was recorded. And through the player, you are able to analyze the log, the basic analysis, but nevertheless the log. For those who are interested in more detailed analysis, first of all, you can do this by yourself because the CSV file is available. And second, we do additional development for those who are interested for, once again, particular analytics based on the raw data, which is stored automatically. CSV file is stored in the dashboard folder. CSV file is stored 24 hours, and then a new one starts. Just not to lose too much data in case of issues. So this is a particular track of a forklift inside a big warehouse. So green dots are our lovely stationary beacons on the ceiling. So this is the floor plan, which you can upload just as a basic graphical format. And the blue is the track of the forklift. It could be forklift, it could be robot, it could be a person. Basically, doesn't matter. What is great, you can build many other things like geofencing, for example, or no driving zones. So there are many zones which help to solve your particular, let's say, requirements or issues. Like, I don't want the driver drives to this area, or I don't want this particular worker to move to this area. So there will be automatic alarm, or it's possible at least to make automatic alarm based on this information. This is valid for drones and forklifts, but even more for robots. For example, I don't want my robot to drive to this area. Okay, you create a no driving zone and the robot doesn't go there. So zones are transferred to you via our system. So you build them inside the dashboard and you send them. Our system, and let me repeat, is indoor GPS. So it's GPS. It's not controller of your robot, so we don't drive your robot. Your robot's controller does it. But what we do, we provide you precise indoor navigation, and we are able to send the data like path or zones from the robot, or let's say from the system to the robot, but we can also send the data back, like some sensor information, some other data from the robot to the system, which is extremely useful in many cases. So you can monitor your voltages or some other things. It's not high speed. It's several 100 bits of second, or maybe a couple of kilobits per second, but still it's far enough for majority of telemetry type of applications. Then, as mentioned, not only robots, drones, but people. So we are already offering helmet, Marvelmind helmet, which is based on Mini RX. And the colleague of mine currently wearing this, so as soon as we will have questions about demos or something, we would be able to show this performance live. Again, for safety and productivity, this is the key. If you know everything about your forklift, even more you can know about your people, prevent them from doing some terrible things or mistakes in dangerous areas, in industrial applications, all kind of geofencing and alarms. They are pre-built and possible, but even more possible with customized development. So this is the demo. Please check our YouTube channel. So you're already on YouTube, that's great. So we try to publish as much as possible. But as a request to the audience in general, ask us more questions and we would be able to provide particular additional videos, demos, or explanations, help videos, how to do demos. Again, send us your feedback and we will be happy to provide even more information. So check our YouTube channel and send us feedback. A few words about future development. So currently our system supports single modem configurations only. So each modem supports up to 250 beacons, which is enough for very large application, but in many cases it may be not sufficient. So what are those applications? Now, obviously, when you have more than 250 beacons, by beacons I mean combined, stationary and mobile. We don't distinguish from this volume perspective. But even more, multi-modem configuration could be required when you have thick walls or higher distance, when the modem is simply not capable to reach. In open space, full-size antenna on 433 megahertz, we measured up to 400 meters. So, for example, if you have a modem, or let's say future super modem, this super modem would be able, in open space, talk to beacons up to 400 meters away in one direction and 400 meters away in another direction over radio. Ideal conditions, but nevertheless tested and possible. But very often this is not available, especially indoor. So this is why this is a demo of how it will look like in a tunnel or in metro or in underground. So you have a super modem which is covering part of the tunnel, this is covered another one. So this is upcoming. There will be a super modem, each of them covering up to 250, and there is also super modem, which is basically combining information from all of these modems into one map, and you see a huge map basically consisting of hundreds and hundreds of beacons as one single map. So we have 3 layers: submap, map, and super map in super modem. This is coming. Again, let's be cautious about timing. We put a lot of efforts to this. We will be happily publishing it. It's now in development, so just for you give a hint, when you grow enough and you need more capacity, I think we'll be ready by that time. About types of beacons. As discussed, different applications require different types of beacons. So this is why we have them really, different type. Mini-RX is one of the latest. It's tiny. It's versatile because it can be used in inverse architecture as mobile beacon and in non-inverse architecture as stationary beacon. It's very sensitive, and as you see, it has only one microphone or one sensor, which is very useful because you don't have to care to switch on, to switch off the sensors. For example, when you switch on all the sensors in hardware version 4.9, sensitivity will drop. You will have widest 360 degrees horizontally and 180 degrees vertically coverage, the whole hemisphere, but the sensitivity will be the least. If you want the highest sensitivity, then you better disable some of the sensors which you don't need. Each of the sensor is roughly 90 degrees beam. In this case, one sensor is capable to cover everything, but as a drawback, it's only RX. So it's not able to transmit any ultrasound. But it's more sensitive, and it's easier to handle, and it's smaller. Mini TX beacon is kind of opposite to this. So this is only RX, this is only TX, and so transmitting ultrasound, and it's also a small one. It's useful for virtual reality application and for drones. For even lighter drones, we have a version without battery. So it's very light. In some cases, we suggest even not to use housing. And as far as I remember, it was like 6 to 7 grams, so very light. And very classical dual use universal beacon hardware version 4.9. So this is very standard for one of us, and probably the most typical one. It's used in non-inverse architecture, but also in inverse architecture when the sensors have different frequencies. So let me remind, for non-inverse architecture, all of them talk on the same ultrasonic, 31 kilohertz usually. In inverse architecture, they must use different frequencies. So Mini-RX is capable to receive all of them, 19, 25, 31, 45 kilohertz, but beacons which are transmitting, they are hardware defined. They're hardware defined, and it means that you must select either 19 or 25 or 31 or 45 kilohertz. This beacon, Mini-RX, can be IP67. So there are 2 options, without IP67 and with IP67. And even for more harsh environment, we have industrial set. Industrial set, unlike all of this except for this, it doesn't have any internal battery. So there is input for the battery, and there is input-output for UART, RS485, and CAN as an option. The same for RX beacon. So a bit more about Marvelmind Watch, or let's say Mini RX in this case. As mentioned, it's tiny, it's versatile, as all of our beacons can be charged over USB, all except for industrial. And running time really depends on the usage. If you turn it on to the highest frequency, it will be around 12 hours. If you use it very occasionally, whatever, one update per 15 seconds or something, it can last up to 1 month. It can be indoor and outdoor, but notice that it has embedded antenna. So embedded antenna usually have lower performance over radio. So realistically, 50, 100 meters at most. So Marvelmind jacket. So Marvelmind jacket, I will talk more about in next slide. It's Mini RX with the jacket. What we try to do, we always recommend to put the mobile beacon as high as possible and the stationary beacons even higher, so to minimize the abstraction. So the best way and the best option would be helmet. If helmet is not possible, then the jacket. If jacket is not possible, then a badge. If badge is not possible, then a watch. Effectively, it's Mini RX with the jacket. A few words, detailed words about Mini, let's say industrial TX. Power supply external, 12 volts, but other options are available. Very protected special sensors. Input-output UART, RS485, and CAN is an option. Very similarly, RX beacon with the same input-output capabilities and with the same power supply. Their beacons is fully sealed in with compound, so it's very well protected. Super modem, which is coming, it's effectively the modem, but with extended capabilities. More power, more capacity, and even more importantly, it has Wi-Fi and Bluetooth internally embedded, so it means that it has connectivity. So effectively, it's a small computer which you can remotely connect in, and the streaming will be done also over UDP if needed. So about Marvelmind Watch, so you have seen demos on YouTube. Please check them once again. So demos in museum or some other demos as well. So Marvelmind Watch is a useful case when helmet or jacket is not possible for some reason. Marvelmind Badge is a new product, so we are introducing this today for the first time. Marvelmind Badge is an extended version of Mini RX with additional external microphones. The benefits are improved tracking in real-life performance, because your body would be blocking the signal, so we help this by providing more microphones, thus by providing more coverage and more stable coverage. Marvelmind helmet. So it's already commercially available. Yes, it's a modified one, so think about certification and all kind of things, but nevertheless, so it's effectively Mini RX with external microphone and ready-to-use helmet. It's IP67, so ready for usage in real applications. So about the jacket, a few words. The same story as with Marvelmind Badge. It's Mini RX with additional microphones to provide better coverage. It's more robust, it's reliable, and it's basically designed for real-time applications when abstractions are very often, and it simply improves the tracking in real time or in real life performance or in real life environment. So for those who are not capable to get our own helmets, we have a so-called Marvelmind headlight, which is basically connected to any kind of helmet. So if you have a certified helmet, so you can use it. It's also Mini RX with additional microphones to provide a better ultrasonic coverage. So that was a bit about our new products. So thank you for listening. And now this is a Q&A session. Please type, and I will be answering. So there are some questions in Russian. I will be able to translate and answer them in English and also show. So the question is, what is the base for stationary beacons for stable mini-RX with high precision? Basically, the answer is the following. It's the same for mini-RX and for all kind of. The more, the better. What is the more? Now imagine a triangle when you are measuring 2D. In 2D, you will have the distance between stationary beacons. Oh, let me try to draw. Give me a second. I will try to find my my paint. So, for example, you have one beacon, station beacon, and another station beacon. And you have a mobile beacon. Okay, color. So this is a mobile beacon. So when you have a obviously short distance here, or short base, and what we do, we effectively measure the distance from this beacon to this beacon. To this beacon. And it means that when you measure the distance with 1 centimeter precision, even tiny change in the distance here would result in quite large error here. But if you place the beacons, the station beacons, farther from each other, this error in positioning would be significantly smaller, because the same error in the distance measurements would result in a much smaller location measurements. Yes, first of all, this presentation is already shared on YouTube, and it will stay there, so you can always play it back. Second, yes, we will upload this presentation, and it will be a link to this video. Answering, yes, it's possible to upload your map. It's like this. You go, where's my mouse? Okay, let me connect to the modem. I'm connecting now to the modem. So the modem wakes up the beacons. We have a submap, and inside the submap, I will need to check with my guys. Sorry. I forgot. Give me a second. Как мне сабмапу подгрузить? План подгрузить.
Картинку?
Да.
Правой кнопкой на этаж.
На этаж, я понял. Guys, help me. So I actually forgot myself. So this is, so you select the floor and load floor plan. So it's here. Because floor plan is basically effectively for each floor. So it's, yes, it's possible. The new product says headlights available now. Yes, we are introducing them today. So for smaller volume, let's say to pilot, to show your own customers, yes, they are available. Availability several days, like industrial applications. So we don't store them. We make them basically modify the existing one, but yes, they are available. I have a few other basic hints. I will ask my colleagues to move. Okay, so this is live performance, and with my mouse. Okay, for example, some basics. I mean, while you're asking additional questions, some basics like instead of last 50 seconds, 5 seconds. Okay, so this is 5 seconds. Trail. Very useful. 50 seconds. If I don't want, I press M. Maria, M. Okay, map is cleared. Just basic hints. Also, we received quite many questions about the latency. So the latency is defined by many parameters, and by default, probably the biggest implication is real-time player. It's turned on. It gives, so this is without real-time player. It has low latency, but as you see, the performance can be as not perfect as with real-time player, because real-time player is analyzing quite many. Okay, my colleague is basically the same route. It's basically analyzing the last several dots and then giving the best performance. So real-time player, you can trade off latency for even better performance. So now I turned on the real-time player, and as you see, it's extremely smooth and extremely. Actually, TDMA system has been already released. Give me a second. I will once again check with the guys. Either we didn't publish, or we will publish. No, anyway, so TDMA is already available. Yes, TDMA, I think in the latest operating manual, it has been published, or at least we are certainly publishing TDMA a lot. And you've seen the video. Oh, let me actually show. I have another TDMA, so currently I'm disconnecting non-inverse architecture, and I'm connecting another modem with inverse architecture. Let me talk about TDMA a bit, because there are some questions. So this is TDMA inverse architecture network, which consists of basically two 2D submaps. One submap, okay, now there was a transitional, so now it's ready. So one submap and another submap. Basics of TDMA, okay, they're basics. All of them have 100% 100% coverage for the territory. Okay, one of the beacons is dropping, I don't know why. 100% coverage for this territory, and you have two actually modes. Okay, it's back. I don't know what was wrong. So the benefits is the following. When the beacon is moving near this area, and we have, for example, some obstacles or something, the system automatically compares all the time the quality of tracking from this submap and from this submap, and automatically choose the best option. And this is so-called TDMA mode 1. So system switches and keeps in one submap as long as the quality is great. But then it moves, and for example, you're moving closer to this, and performance in this would be better, and it switch to this submap and keeps in this submap, or let's say in these beacons, as long as the quality is great. So this is mode 1. In mode 2, so this is, I will not switch it, but in mode 2, you can, the system is actually switching all the time. Submap 1, submap 2, submap 1, submap 2, submap 1, submap 2. Let's say every second measurement is between different. So this system has pros that it's always have at least some great tracking. But the first one is better when the tracking is great, so it provides better tracking. But when the tracking is terrible, let's say a lot of abstractions and a lot of issues, the second mode could be better. It's very important that in TDMA you use real-time player, because real-time player is basically smoothing the jumps between these two submaps, because they must be aligned. There are always some obstacles, there's always abstractions, but as soon as you enable TDMA and real-time player, the quality of tracking is usually very great, even with challenging conditions. So now my colleague will be moving. Okay, so this is currently TDMA live. Okay, there's another question in Russian. Okay, 100 hertz. So there was a question how to achieve 100 hertz. 100 hertz with IMU is possible currently in non-inverse architecture. In inverse architecture, IMU fusion is coming, but the key point is that you need to enable IMU fusion, and you must get the location data from the mobile beacon, because it's impossible to stream 100 Hz update rate from the modem. Modem will still be getting location data only ultrasonic based, not from the IMU. So let me repeat, 100 Hz is possible in non-inverse architecture and only from the mobile beacon. In order for the IMU fusion to kick in, I mean, really works, so you need to have at least 4 to 8 Hz ultrasonic. Because how IMU works is basically extrapolating based on double integration of IMU, extrapolating the location. But this extrapolation and IMU drift very quickly accumulates errors. So this is why we cancel those errors often. How often? 4 times per second. If you do it 1 time per second, the error will be just too big already. And okay, depending on your applications and requirements, but it will be a matter of some bigger centimeters than 2 centimeters. This is why we suggest and actually require that in ultrasonic you achieve at least 4 Hz update rate. Then you enable stationary this IMU fusion, and from the mobile beacon you will be able to get 100 Hz. Okay, well, no more questions. Let me switch. Let me try to now to show the performance. Where's my mouse? The performance. So let me zoom in. I'm zooming in very simply by the mouse. So for those who don't see it, so currently 5 centimeters. So this is their performance with real-time player enabled, and this is okay. So this is live now 5 centimeters in this. So this is our lovely ±2 centimeter with latency around. You have 8 Hz update rate, and you have 3. So it's around 0.2. 0.2, so 2 Hz update rate. Yes, so answering, yes, it's possible to create virtual fence. This is what I was referring as geofencing. Yes, it's possible right now. It's possible to build geofencing. Let me ask my colleagues. Okay, my colleagues are helping me. So zone setup, and here you can create different types of zones. Handover, zone disable. Check in the manual. So anyway, so it's possible, different types of zones that I mentioned, and it's right-click on each of the submaps. By any sound and not allowed to robots. A couple of comments about not loud. Inverse architecture, by definition, is more sensitive to the noise near the robot. So, for example, if you are flying drones, we certainly recommend non-inverse architecture. Because in non-inverse architecture, mobile beacon is emitting sound, and station beacons, which are usually far from the noise, they're receiving sound. So if you have additional, let's say, big noise, then of course use non-inverse architecture. But nevertheless, in majority of cases, inverse architecture is just good enough. And what you could do, I'm basically answering to Alex Romanov. Check that your jumps are related to the noise, but not to the abstraction. But because in majority of cases, it's not because of noise, but because of abstractions. You still must provide the very fundamental thing of the system, direct line of hearing to 2 or more station beacons for 2D or 3 or more station beacons for 3D. Second, check your settings, because maybe the signal is just weak. And it's easy to do, and we strongly recommend to use oscilloscope. There is embedded oscilloscope inside. So, for example, I want to see how my mobile beacon in inverse architecture listens to, so I'm selecting from beacon 2 to the mobile beacon. And as you see, it's extremely strong signal, and I see the trigger. So I want to check from beacon number 5, or whatever number, from beacon number 5. Okay, it's slightly weaker, but still extremely strong signal. It also depends on the gain and many other parameters. But nevertheless, always use the oscilloscope in case you have any kind of doubts or any kind of issues. So oscilloscope is extremely powerful and available for monitoring. Second, it's about settings. For example, in beacon, I would be also checking what number of periods or pulses do you emit. In default, we recommend 5, which is okay for 5, 10, whatever, 15 meters. But when the distances are more, increase it. Increase it to some other values, 15, 20, up to 50. What else? Such sounds to, you know. No, I already answered. So ER is more prone to the noise, and check ultrasonic settings, check the oscilloscope, and increase the number of periods if needed. And in case the noise is still high, decrease their distances. So in, let's say, normal conditions, it could be up to 30 meters, decrease to 20, decrease to 15 or 10 again. And check that this is actually noise related, but not abstraction related. So live event with loud music possible. Oh, of course, we have participated in many different events, exhibitions, and all kind of. So yes, it is possible. It's always a matter of how loud. Is it loud in sound or in ultrasound as well? So not necessarily everything which is loud in ultrasound in sound is loud in ultrasound. What are the distances? So it's basically signal to noise or signal to interference ratio. But based on practice, usually when we are on an exhibition and there's music and you know, there's a lot of Wi-Fi, etc., we simply work. Sure, one inverse architecture. No, currently, non-inverse architecture is supporting 100 Hertz, and inverse architecture is not yet supporting because inverse architecture is more, let's say, newer. So we are just developing and basically porting. So it's not yet available, but it's planned to be available. You're very welcome. I wanted to show also another hint. I don't know does work in this architecture, but it may be useful in some cases. I will switch on to non-inverse. For example, I want to change the position of my axis. And it's done by this. So you type, so this would be my starting beacon, this would be my X, and this would be my Y. Okay, that's it. It's rebuilt. Okay, now it's basically found a new position. It's very useful. Also, double-clicking the map does this, for those who are interested. What else to show? Ask questions anyway. I will be happy to answer if any. I guess you must have many questions and many doubts, so ask, shoot, challenge. And once again, after this session, please, if you recall something that was not covered or some particular question, send us additional details, or let's say additional questions. And first of all, we will introduce this and would be starting point with the next session. And second, we would be able to update our manuals or update our demos, hints, and so forth. So use this session as an opportunity to give us a feedback, so we would be able to provide you even with more details for the future releases or for the future help files or help videos. No, basically, I don't want to occupy any more time from anyone. So I think it was a hopefully useful demo. As mentioned, this will be available on the website. We will link the presentation. We will link to those documents that we showed. And we plan to have these sessions at least once a month. So if no more questions, I will be closing the session. And thank you very much for everyone.